A survey of 38 people was conducted to compare their self-reported height to their actual height, and the difference was calculated. You're testing the claim that the mean difference is greater than 1.2. From the sample, the mean difference was 1.25 with a standard deviation of 0.46. Calculate the test statistic rounded to 2 decimal places. Okay, so here's our objective. We are going to calculate a test statistic, which means we're going to need a formula. And in order to choose which formula is appropriate, you have to identify what kind of test it is. Here we were given a sample of size 38, where we're comparing the difference between two pairs of data, paired data. So someone's reported height, just what they estimate they think their own height to be, matched up against their actual measured height. So these are matched pairs, and this will be a matched pairs t-test. And then we are given the information that we will need to plug into the formula within this part of it, and also we will need the sample size from up here. So let's go ahead and look at Excel. I've started off by just identifying that we are doing a test of the mean of the differences for matched paired data. And our claim was given here and written in symbols. It looks like this, the Greek letter mu with the subscript d to remind us that it's the mean of the differences of matched pairs. So the mean of the differences from the population is claimed to be greater than 1.2. Since there is no equality in the claim, it became our alternative, and we are looking to support that alternative by finding evidence against the default assumption, which we call the null hypothesis. So we have this one case. We're saying, okay, let's assume that the null hypothesis, let's assume that the mean is actually equal to 1.2. Now, from our sample data, it may indicate enough evidence to reject the null hypothesis, and that would allow us to support the alternative. So we're going to use that sample data. We're going to need it, so we're going to do the sample mean. Oops, I think I need to make a correction here in my file. Okay, so I've just made a place to record all of our sample information. We have the mean difference. The mean difference was 1.25. So normally when we talk about the sample mean, we use the symbol X with a bar over it. Now we're just going to use a D with a bar over it just to remind us that it is the mean of the differences. So 1.25 is our D bar. And the standard deviation is also given here. So this is the standard deviation of the differences. That's 0.46. And the sample size was given up here as 38. Now, we need to go looking for our test statistic formula. So in other words, we take our statistic, which is the sample mean, and we standardize it to a t-score so that we know if it's very abnormal. If it's very, very abnormal, then we will reject the null hypothesis in support of the alternative. So how do we determine if it's normal or abnormal? We will standardize it similar to the z-score formula that you've worked with before. You take your sample statistic, you subtract the value claimed in the null hypothesis and see how far apart they are. And if they're very far apart, when you try to divide it by the standard error, you're going to get a number that's far away from 0, indicating that it's probably not a fluke and something significant that would allow you to reject the null hypothesis. So now let's calculate it using the formula. We have T, which is our test statistic, TS for test statistic, T equals. And then let's do a little bit of prep work actually before we even do that. Notice that in the bottom I have S sub D divided by the square root of N. We sometimes call that the standard error, SE for short in some cases. And we can calculate the bottom portion ahead of time so that it's easier when we go to do the big formula. So I'm going to do the bottom part. I'm just going to do the sample standard deviation divided by the square root of n, which is 38, and is stored here in cell B9. So I'm just going to type that in, B9. All right, so there's my standard error. So now this is going to be simpler. In the top of my fraction, I have d bar minus the mean. Okay, now which mean do I use? I use the one that was part of the claim, right? So 1.2, we always do it under the assumption that the null hypothesis is true, and then see if we have enough evidence to reject it. Then divide it by the standard error. So here is my test statistic. And that is all we were asked to do here is calculate that value. We weren't asked to assess whether or not we think it is normal or abnormal or usual or unusual, if it's significant or not significant. We weren't asked to think about any of that, just to calculate it. So we're focusing just on the calculation. And there is your answer rounded to 2 decimal places. And we're good to go.